So, hello everyone. My name is Vikas Kumar Singh, and we are back with the assignment number 3. And today we are going to solve the assignment number 3 from the class mechanics of metal forming, sheet metal forming. So, I am going to solve this assignment today. That assignment is already shared with you from the NPTEL course, SWAYAM course. So, in this class, we are going to see basically the drawing process, sheet metal drawing process, and all the problem will be related with the sheet metal drawing process. And pure shear means deformation in pure shear and deformation in pure shear, stress, strain, all these things will be there. So we'll start with assignment number 3. So already the concepts are all explained in the class, recorded class. So here we are going to solve the problem only, numerical problem. So just bear with me. So the first question here is, so that in equal biaxial stretching, the sheet thickness decreases rapidly with respect to major strain when other compared to the other process. So we have to show this thing. And the first part and the second part, the effective strain is twice that of the major strain. This one we have to see. So first of all, I would like to explain what is the equal biaxial stretching means. So when this equal biaxial stretching is there, so means your sheet is stretched in two direction. One in, suppose in this direction your sheet is being deformed, the another direction will be like this. Okay, so but in the both the direction you have, suppose this is epsilon 1 and this is epsilon 2. So in the both the direction it will be deformed. Okay. The next part here, nothing is said about the plane stress strain condition. So we will consider the third dimension also, that is the sigma 3. So we can consider sigma 3 in this direction also. Okay, so sigma 3 will be in this direction. Or another way we can say, suppose this is sigma 3 or this is sigma 1 and sigma 2. Sigma 1 and sigma 2, this is sigma 3. Why I am telling? Because this one we can consider one plane in this direction, one plane which is this plane, and the perpendicular plane will is in this direction, so we can consider like that. Okay, so generally sigma 3 is the thickness direction. Okay, so let us start. So in biaxial equal biaxial means in plane your strain will be same, in plane strain will be same, sigma 1 and sigma 2. So this one is sigma 1 in this direction and this one is sigma 2 in this direction. So what about, so I am just taking sigma 1 equal to sigma 2 equal to, sorry, epsilon 1 equal to epsilon 2 equal to epsilon. So epsilon will be same in plane for biaxial strain. So sorry, I have read this one as a sigma. It's not sigma, it's epsilon. So for the volume consistency, epsilon 1 plus epsilon 2 plus epsilon 3 will be equal to 0. So what next? So the next part, if we are putting this condition here, we will get sigma epsilon 3. So epsilon 3 will be minus of epsilon 1 plus epsilon 2. And if we will put all this value, you will get minus of 2 into epsilon. Okay, so sigma 3 equal to minus of 2 into epsilon. This is coming from the volume consistency. What does it mean? What is the meaning, physical meaning of this? So this indicates that in thickness, so I just already told you, sigma 3 is the thickness direction and sigma 1 and sigma 2 in plane. Again, I'm making mistake. Epsilon 1 and epsilon 2 in plane strain and epsilon 3 is in thickness direction. So this indicates epsilon 3 is twice of the in plane strain. It means in plane stretching is there. So the third dimension deformation will be twice of that. So it will be much more faster in the thickness direction. This means this. So the first part of the question, the thickness, sheet thickness decreases rapidly with respect to the major strain. So major strain is sigma 1, epsilon 1 and epsilon 2. Okay, so the thickness direction, this is decreasing rapidly. So minus is telling the decrement, and epsilon is the major strain in plane. So this is proved. The effective strain is twice that of the major strain. The second part, effective. So you know the effective strain formula, epsilon bar equal to 2 by 3 into epsilon 1 square plus epsilon 2 square plus epsilon 3 square. This is the formula and root under of this. This formula is already derived in the lecture class, so you can see that. Okay. So here we can put epsilon 1, epsilon 2 are equal, and that is epsilon. So we can put 2 by 3 epsilon square plus epsilon square plus minus of 2 epsilon whole square. And this is whole bracket and under root. So now if we will solve this, we will get what? We will get this one will be equal to 1, 2, and 4, 6. So 2 into 6 by 3 epsilon square. Yeah. So this will give 2 into epsilon. So effective strain is going to be twice of that of major strain. So this twice is here. So this is solved. This problem is solved. So here the point is, whenever it is coming equal biaxial, equal biaxial, equal biaxial. So equal biaxial, whenever it is coming, you have to consider it as epsilon 1 equal to epsilon 2. Okay, and the third dimension you have considered from the volume consistency. This will come at minus of epsilon 1 plus epsilon 2. Okay, this was one of the concept what is given, and when it is given plane strain condition, plane, then what you have to consider. So if it is given plane, then you have to take epsilon 3 will be 0. But here plane strain is not given. Plane strain is not given. It means you have to consider the epsilon 3. Otherwise, this will be 0 in the case of plane strain condition. Okay. So going to the next question. So here this is a little long, means the content of the question is too much, but don't worry, we can solve this problem easily. So you just have to follow all the concept. Here it is given a sheet of 0.8 mm thickness. Sheet of 0.8 mm thickness. Here 0.8 mm thickness is deep drawn to generate a cup. So this is going to be something like this. A cup they are making like this. Okay, so when they are making the cup, this part is the flange part, this part is flange part, this is the wall, and this is the bottom part. Okay. The bottom means this part. So I am just denoting with some number. Something will be given. Location A it is given. So this is suppose A, this is B, and this is C. Okay, this part and this part is same. This part and this part is same. Okay, so A, B, C, 3 locations are given. So bottom, a cup with the bottom A means A. A strain is given epsilon equal to 0.015, undergoing a biaxial stretching. Again, biaxial means see epsilon here, location A, equal biaxial stretching means epsilon 1 will be equal to epsilon 2. Okay, and we can find out epsilon 3 from the volume consistency. So we can get that volume consistency. If you are putting the epsilon 3 will be minus of epsilon 1 plus epsilon 2, and this value will be something minus of 0.03. coming to the question, B, at the location B, a cup wall with a strain is 0.05. So at this location, a strain is 0.05. At the midway following the plane strain, here it is telling plane strain. The location A, it is said like here we have biaxial stretching, here we have a plane strain, and the third location they are telling strain ratio is given. The third location they are giving R. R means a strain ratio, sigma 2 by sigma 1 value is given. So everywhere the calculation of sigma 1, 2, 3 are different. Here we have to follow equal biaxial stretching. Here we have to follow plane strain condition. Here we have to follow a strain ratio. Okay. So material does not strain harden with a constant. Material does not. Okay, the strain hardening is not there. That N value is not coming. We have to just take the flow stress of the value 300 MPa. Now we have to evaluate the major tension. Means tension, you can say traction. So traction is given in the term of Newton per meter, means force per meter. Okay, required at 3 different locations, and give answer in the sequence. Location major tension in location A, major tension in location B, major tension in location C. So at all 3 location we have to give the tension in term of kilonewton per meter. So this is nothing but a traction. So here it is denoted, traction is given, written as a tension here. So don't confuse about the unit. Whenever it is given in per meter, it is traction. Now, so how to calculate that traction? The question is how to get that traction value. So to calculate traction at each location, what we need. So the traction value, sigma, I'm just denoting the traction value with T. You can I can write T. Traction value is given as effective stress or flow stress at that location into thickness, current thickness at that location. So this will give the traction value. So now after the deformation, what is this value and what is this value? We have to find out. So at each location, the T will be given equal, T will be given as T equal to T naught E of epsilon 3. And epsilon 3 is the strain in the third direction, like in plane strain, in plane, whatever major strains are there, sigma epsilon 1 and epsilon 2, and thickness direction it is epsilon 3. So the thickness direction, exponential of thickness direction into the initial thickness. So initial thickness is given here 0.8. So this value is also given. So and now we have to find out epsilon 3 at each at all the location, all 3 locations. So if we are able to find this, we can find thickness and we can put it here. And how to find this value? So to get this value, what we have to do, sigma f, we can write sigma by 1 minus alpha plus alpha square. This formula, you know, this is coming from the derivation of the equivalent stress, and alpha is the stress ratio. So alpha value is nothing but a stress ratio, sigma 2 by sigma 1 we can get. Okay, so alpha value, how to get the alpha value? Okay, alpha value we have to find out. Okay, so once we will get the alpha value, we can get sigma f at each location just by putting this, and this value is given in the question. How much? This value is given in the 300, 300 it is given, 300 megapascal. So we can find out this value. So at each location, we have to find at each means, I mean to say at each condition, in the every condition A, B, C, what is that alpha value and what is the thickness value. Once we will get this, we can find out the traction. So that the given location, we have to find epsilon 3 also. So in this condition, what will be the epsilon 3? So in this condition, epsilon 3 will be minus of epsilon 1. Why? Because this is the plane strain condition. So plane strain condition, and only 2 strain will be there. So now epsilon 2 will be 0 in this condition. So epsilon 2 I am keeping here, it is 0, and this value will be minus of 0.05, which is given. And in this condition, epsilon 2 by epsilon 1, this R value is given. So from here, epsilon 2 will be R into epsilon 1, and this value will give epsilon 2. So epsilon 2, if you will put this value, you will get minus of 0.667 into 0.15, this value. And epsilon 3, from where we will get? Epsilon 3, we will get minus of epsilon 1 plus epsilon 2. So we will get all these things. So at each location, A, B, C, we got epsilon 3. So we got epsilon 3. So epsilon 3 we will put in this equation, we will get the thickness at each direction. That is clear. Now at each location, we have to find sigma f, and to get the sigma f, we need alpha. And alpha is nothing but your stress ratio, sigma 2 by sigma 1. This is stress ratio. So this, how to get this value is the question now. So to get this value, we have to follow this formula. What is the value of epsilon 2 and what is the value of, sigma 2 and sigma 1. Okay. So to get the alpha value, now we are coming to calculate the alpha value. So here alpha at location 1, what is the alpha? So at location 1, it is given what? It is given So sorry, there was some internet issue was there. That's why it was disconnected. Okay. So now we have to find out the alpha, and alpha is this. So we know if we have epsilon value is known for all a sigma 1, epsilon 2, and epsilon 3. All three's value are known at all three locations A and B and C. So we can find out beta, and beta is nothing but at every location sigma 2 epsilon 2 by epsilon 1. So this is the formula for strain ratio. So alpha in term of beta is known, and that alpha in term of beta equal to nothing but 2 into beta plus 1 divided by 2 plus beta. This formula. So if we calculate beta at every location, so we can. Why not? Because everywhere we have epsilon 2 and epsilon 1 at every location. Epsilon 1, epsilon 1, epsilon 1, epsilon 2 also we can calculate using this rule, equal biaxial. And here plane strain also we can calculate, and strain ratio also we can calculate. So once we will calculate the alpha, beta, we can put it that beta value for each location. We can put that beta value. So in the alpha value in this location. So what will be that value? So beta in the first case, I will solve first one. So in the first case, it is given this condition, equal biaxial stretching. In this case, beta will be 1. So in this case, alpha will be what? 2 into 1 plus 1 divided by 2 plus 1. Okay, so this value will be 1. So alpha equal to 1. So alpha equal to 1, then we can put sigma by 1 minus alpha plus alpha square root under. Okay, so 1 value, if you are putting, this whole denominator will be 1. This will be 1. So this is nothing but sigma. And sigma value is given is 300. Okay, the sigma f value is 300 is known. Now traction is how much? So traction is sigma into t. So we can put this value 300 here, and t, how to calculate? So t equal to t naught. It's nothing but 0.8 mm. I am just telling mm. E to the power epsilon 3. So in the first case, what is the epsilon 3? 0. Minus 0.03. So here we can put 0.8 into e to the power minus 0.03. If we will solve this t value will come in term of mm. Okay, so this value will this value, if we are once we will get, we will just put it here and multiply, we will get the traction. So all the calculation is here. You can see in the first case strain, this is epsilon 1 and this is epsilon 1, epsilon 2. We can calculate epsilon 3. Here also it is given plain strain. This one was given biaxial stretching. This one was given plain strain, and this one strain ratio was given. Okay, so this one is again epsilon 1 and epsilon 2. This one is given epsilon 1 and epsilon 2. So the ratio, you can see this value are same. So beta is nothing but epsilon 2 by epsilon 1. So this value will be 1, this value will be 0. And similarly, this value will be minus. Just divide this. Then we can get the alpha value. Alpha value is 2 into beta plus 1, 2 plus beta. So you just put that value, you will get alpha equal to this. And here you will get alpha equal to, if what will be the beta? 0. So once we will put here 0, so this will be 0, 1 by 2. So this will be 1 by 2. Similarly, for you will get at location 3. Now thickness, already we have calculated this formula from volume consistency. So here beta, in terms of beta it is given, but also you can calculate sigma 3 equal to minus of epsilon 1 plus epsilon 2. You just put this value, you will get. So this one and this one, all thickness value. Thickness strain means epsilon 3. This is nothing but epsilon 3. Here also epsilon 3. Here also epsilon 3. Now thickness, you can see here the formula is given. So you will, if you will put this, so it's 0.8 into e to the power minus 0.03. So this value will be nothing but this much. Similarly for this and for this, it's all are in mm. Now we calculated alpha also. Alpha is 1 for at location 1, half at location B, and minus 0.251 at location 3. Once you will put this, so this value is given in the question here. This value is given in the question. This value here. Okay. So the actual formula of this is sigma by 1 minus alpha plus alpha square. So you have to put all this value. So you will get stress at all three locations, and once stress is given, stress is calculated, you can calculate traction at each location. How? Just multiply this with thickness. Just multiply with thickness at each location, you will get the traction. So I hope this problem was easy. Just it was big, means that content was big, and the question means what they are asking were so many things where they ask. So systematically I solved this here. Now going to the next question. Here it is given in the deep drawing process again, so that the flange deep drawn cup following pure shear mode deformation. Pure shear mode deformation. So we have to prove it. We have to prove it. It is following pure shear mode deformation. So that in the flange cup following pure mode deformation, we have to prove first thickness strain is 0, and second effective strain is 1.155 into measure strain, and the third one is the effective stress is 1.372, means √3. It's 1 by √3 times of stress. Now, what does it mean? Pure shear mode. So you know pure shear mode, it means we have a strain. If you have followed the derivation, strain is equal to this one, and even stress is sigma 1 equal to minus sigma 2 in pure shear deformation mode. Now, what will be the beta in this case? So beta will be minus 1, because beta equal to nothing but epsilon 2 by epsilon 1. So this will be minus 1. Okay. So what will be the epsilon 3 then? epsilon 3 will be nothing but minus of epsilon 1 plus epsilon 2. And you can see from here, this will be 0. Okay, so thickness is going to be 0. So thickness strain is 0. And I told you, like, suppose we have a plate like this. We have a plate like this. So we are considering one direction in this direction. This direction is one direction. This one is another direction. So we can think of epsilon 1 and epsilon 2. And the third dimension, that is thickness dimension, this is epsilon 3. This is the convention which we are following. So epsilon 1, epsilon 2, epsilon 3. So epsilon 3 is always thickness direction. Okay, so this is proved. The second part, what is the effective strain? So effective strain epsilon bar is equal to 2 by 3. This formula you are knowing, 2 by 3 epsilon 1 square plus epsilon 2 square plus epsilon 3 square. Okay, and root under of this. So now you are knowing this is 0 in case of pure shear mode, and the epsilon 1 and epsilon 2 are equal, and this value we can write minus of this, so square is there, so this will become plus this value into 2 by 3 and root under. So this is going to be 4 by 3 epsilon square and root under. So this is going to be 2 by root 3 epsilon square. If you will solve this, 2 by root 3 will give 1.155 epsilon value, major strain. So this is the effective strain in case of pure shear mode. Okay. Now, what will happen in the pure? What will happen to the effective stress? So I told you here already. This part here we are writing sigma 1 equal to sigma minus sigma 2. So in case of stress, this is the condition for pure shear mode, and that you can derive. You can derive from the von Mises criteria as well. So the derivation is already done, so I'm not going to the derivation. So once this is done, and if you are following the von Mises equivalent stress condition, so this is nothing but here sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square, okay, and plus sigma 3 minus sigma 1 square. This formula, if you are following, and this is the root under, and you are converting this formula in term of alpha. Alpha is what? Alpha is sigma 2 by sigma 1. If you are converting this term in term of alpha, putting all the condition, okay, so this will become 1 sigma 1 into 1 minus alpha plus alpha square, and this will be under root, obviously. So this will be formula for effective stress, and you just put the value of alpha. What will be the alpha here? You just put that value and you will get the this effective stress. And alpha, you are knowing, these all are equal and opposite. So this will give minus 1. So minus 1, it means 1 by 2. Obviously here this value is going to be 1 minus 1 plus 1. So this will be cancelled. Okay, this will be cancelled. Okay, sorry. Again, some network issue is there. That's why this is disconnecting. Now, the minus 1, we are putting that value minus 1. So what will happen here? Minus, this will become plus 1, and this will also 1 minus 1 square, this will become 1. So root under 3 into sigma 1. Yeah, into sigma 1. So this is actually nothing but this is coming, this part is up to here only. So this is not over here. This is not over here. This is up to here only. So this is going to become √3 into sigma 1. This is the effective stress part, and this is going to be 1.732 sigma 1. So basically, in this question, we discussed the condition for pure shear mode. What will be the condition in the case of strain, and what will be the condition in case of stress? So the basic thing what we got is stress will be equal and opposite in magnitude, and similarly strain will be also equal and opposite in magnitude. Okay. Now coming to the next question. So next question is very easy, and I hope this is objective question, nothing but this is very simple. And what we are going to discuss in this question, again, equal biaxial stretching, the sheet thickness decreases rapidly with respect to major strain, the following this formula. So again and again, this term is coming, biaxial stretching. So I would suggest you people can go through the detail of equal bias stretching in the theory class. And if you have doubt, you can ask, or we can take another session where we will discuss what does it mean and all the fundamental which you are not getting in the lecture, recorded lecture. So live session you can interact. So equal biaxial, again we have epsilon 1 equal to epsilon 2. Okay, equal biaxial. And what about the epsilon 3? Because here there is nothing is told in terms of plane strain, plane strain condition is there or not. So nothing is there. So we have to consider the epsilon 3 also. So epsilon 3 will be minus of epsilon 1 plus epsilon 2. Okay. So now if we are putting this value, so what it will be? This will give minus of 2 into epsilon 1, or you can write epsilon 1 or epsilon 2, whatever. So this is the condition. So here minus of 2 will come, minus of 2. So this is very simple question actually. Suppose they are telling there is no epsilon 3, then what will happen? This will be 0. So that question will come next. I will explain that question also. Here in equal biaxial stretching, here it is, they are asking effective strain. What will be the effective strain? So you know the formula for effective strain equal to 2/3 epsilon 1 square plus epsilon 2 square plus epsilon 3 square. Okay, this one. Now, what is equal axial, equal biaxial? So equal biaxial means this is going to be equal to epsilon 1 is going to be equal to epsilon 2. And what about epsilon 3? So epsilon 3, we can consider what? Minus of epsilon 1 plus epsilon 2. Correct? Minus of epsilon 1 plus epsilon 2. Now, if we are putting all this value over here, what it will give? This will give epsilon 1 square. I'm writing in terms of epsilon 1 only. This will also epsilon 1 square, and plus epsilon 3 will come. Okay, epsilon 3. So epsilon, this is they are equal, so I can write 2 into epsilon 1. So epsilon 3 is minus 2 into epsilon 1 square, and this is going to be, this is under root. So this is going to be 2/3, 1, 2, and 4, 6 epsilon 1 square. So this is going to be 4 epsilon 1 square root under root. So this is going to be 2 into epsilon 1. So this is the effective stress. Sorry, strain, effective strain. Okay. Now we have solved this. Now the question, if somebody will ask, like we have equal biaxial, if instead of equal biaxial, somebody can put a condition of plane strain also, plane strain. what will happen if plane strain is there. So you must be ready for this type of question also. And when it is coming, then your one strain is going away. You have only two, one and two. Suppose we are plane strain we are doing in plane, like see here we can understand using one example drawing simple. So plane strain, if somebody is telling in which plane, either in this plane or in this plane. Okay, so you must be considered which one out of two, which one out of these three, which one is zero. Okay, so if we are talking about in this plane, so we are not thinking about the sigma epsilon 3, this is zero. If we are talking in this plane, okay, so you must be ready for this type of question also. So if you will remove one, means sorry, epsilon 3 from this question, this will give another condition. So and if you are solving that problem using plane strain condition, so effective strain will come this one. Okay, so this condition can also be asked. So the point is you must not ignore what is the condition given in the question, that is biaxial equal stretching or plane strain condition. And for the cup, you must not ignore. If you have a cup like this, so this is the flange part, this is the wall part, and this is the bottom part. So where is the plane, or everywhere we can apply that thing. So in this plane, which strain we have to ignore, in this plane which strain we have to ignore, and which plane in this plane which strain we have to ignore. That is the main point, like where you are considering sigma 1, sigma 2, and sigma 3. If it is given, you have to take plane strain. So this is very important, so please look into it, and if further question will come, we will discuss. Coming to the next question, so here we have in the plane of a deep drawn cup following shear mode of the deformation. Again, we have shear mode, and for shear mode, as in the previous question itself, we have discussed what will be the condition, and like what will be the condition for strain and stress as well. So we will just once more we will solve that, and we will see for the pure shear mode we have this condition, pure shear mode. Okay, so what does it means pure shear mode? I will explain with the one example, like when you have a deformation like this, biaxial deformation. This is suppose this is a block where you are, I'm just giving one example. So instead you are putting biaxial loading like this. Suppose you are putting biaxial loading like this. This is the only tension you are putting. Suppose you are putting shear also like this, shear also here. So now you delete this part, stress part, then you have only shear stress. This is the normal stress. So you have only tau now, tau. So in this case, this tau, in this case, this is called there is no plane, no normal stress in this plane, in this plane, in this plane, in this plane. So for this plane, we have only shear. There is no normal stress. So this is nothing but your pure shear. Okay. Now coming to if you will derive the formula for this, even in this, if you will change the plane. Suppose I'm telling about this plane, there is no normal stress on this plane. But if you will go other than this plane, suppose in this plane, you will have normal stress in this plane. You will have normal stress or compression, whatever. Normal stress means that may be tension or compression in this plane also. So it does not mean that if we are giving only shear stress, in every fiber, in every plane, there will be shear. It does not mean like that. If you will change the plane, you will have different state of stress, different state. Okay, so here we have, if I am writing in term of coordinate, so coordinate means I am writing first coordinate as a plane normal stress and second coordinate as a shear stress. So this is the state of stress in this plane. Similarly here also, and here also, but in this plane or other than this, all these four plane, in this plane or in this plane, we will have this part and this part. Okay, so don't confuse about that. Okay, so that is already derived and explained very well in the previous lecture. So now coming to the question, this is the condition for pure shear mode. Now we have to derive what is the epsilon 3. So this is very simple. Again, volume consistency, we have to apply epsilon 1 plus epsilon 2 plus epsilon 3 equal to 0. So epsilon 3 equal to nothing but minus of epsilon 1 plus epsilon 2. And this is going to give what? This is going to give epsilon 3 value, and epsilon 3 is minus of 2 into epsilon 1. We can. So same question multiple time they have repeated. So doesn't same question. Yeah, same question. It is repeated. So now there is nothing. Yeah, there is nothing shown in this question. There is no such point written like plane strain condition and all. If they are writing plane strain, then we have to consider one strain is going away. So in that situation, the condition will be totally different. Okay. So I hope all these things are clear. So thank you. We'll see next assignment, or any theoretical part is remaining related to all these things. I can explain in the next class. I can take some problem related with the theory. Other than that question, we can solve that problem also. So we'll see in the next class. Whatever is coming according to the response, we will proceed. Thank you.